I'm Nika, and a couple of us will be presenting the project that we came up with. So, we're very new to the concept of biofoundries, but we think that this could make a good one. Uh, our project is based off the idea that a lot of projects are based on science, and it's kind of difficult for them to scale it up to a bioreactor stage because lab scale experimentation can be quite different from how it does work in the industry in terms of production. And uh, yeah, so we decided to create an open source software that is able to simulate and make a bioreactor CAD model and also help you in fabricating the model in real life as kind of a DIY model. So moving on to the problem. So we feel that a lot of people in the scientific community that focus on the biology aspect do not know the concepts of bioreactor design. That's more of an engineering side of things. So designing one can be a daunting task, especially when you're just an undergraduate student who's focused on the science. And even if you have designed something, fabricating is quite difficult, and there's a lot of middlemen involved, and it might be a bit costly as well. So yeah, we think that even if you have the scientific aspect, scaling up should be more frequent and more important and stressed on. So um, even though there are softwares that focus on parametric modeling and do have this already, they are quite expensive and they need licenses, especially on ANSYS. So we think that anyone who intends to make a bioreactor for their project to test scaling up could make use of this biofoundry. Anushka will take over now.
So our solution, as Megha said, is an open source design and parametric model. Now, this is a photo of our team. We are an iGEM team that's participating in iGEM 2021. And early on in our iGEM journey, we realized that upscaling is one of our strong points, as we are a team from a university that is good at industrial biotechnology. We also realized that there are a lot of iGEM teams that do not propose or design a bioreactor. And this is where we realized we could make something to give back to the community. So a few important milestones when it comes to realizing that this is something that we want to go ahead with. That in June of this year, we had two team members, Molly and Maurice, join us to our team, and we began working on a solution. In August, we finalized our project being a software solution, as there exists softwares to design bioreactors, but they're either something that's not very easy for biologists to use or understand or begin using, or are licenses that are very expensive and are not that feasible to apply for iGEM projects or any other projects, because, like I said, they're very expensive. And which brings us to currently in October, where we are almost completely done with our solution, and we're ready to present it. Maurice will take over.
Yeah. So the science behind this is basically we use an open source Python library called CatQuery. CatQuery is a very well documented tool that allows us to code in Python and use parameters for our code itself. So that way the model, whatever we build, can be scalable. Now, how frugal biostack we think can improve the solution? Basically, we want to make this as accessible as possible. And currently we focus on the software, but then the hardware and wetware aspects might require more expensive. Basically, what we're trying to do is if we get many people to accept it, it would be, since it's an open source project, people can keep developing it over and over again. So that way we can keep making the project way better. Now, we assume that the user might not have sufficient knowledge on bioreactor design and implementation or know how to use existing softwares. So we've made the interface very, very, very user-friendly. To just make a basic bioreactor design, all the user needs to do is put in three parameters or three inputs. One is your volume, one is your length to diameter ratio, and the other one would be statement of purpose. So we would have the impeller types according to the statement of purpose. We would have the bioreactor design according to the volume and length to diameter ratio. This is the product. This is how your final CAD model would look. And this is done in Fusion 360, but CAD query, using CAD query, we would get very similar results. Our project provides a scalable solution using certain design rules that can be updated anytime by anybody as it's open source. The fluid simulation would be done using OpenFOAM, an industry standard. So we will create and run modules that allow OpenFOAM to take a mesh CAD model from the STL file and run simulations on that, depending on certain other parameters that we use. What we want to try and help the community as much as possible to make the project more feasible. So generating a CAD model, we get that it's feasible, but this one over here, you don't really have to start from scratch over and over again. All we got to do is input parameters and add rules to the list of existing rules. And we think that different scientists might be able to help us make the software way better than it is.
Thank you. Our presentation was very short, and we hope you guys have questions for us.
Perfect. It was right under 5 minutes. That was great. Any questions from the audience?
Actually, I really want to see like what the software is like, if it's possible or okay.
Could you repeat that? I couldn't.
They're asking about the software.
Yeah, like I really want to see like what the software looks like.
Do you want to see the source code for the software, or like?
Yeah, how does it look like for the user? Like how do they use it? Something like that.
We haven't worked out the user interface yet, but we have the backend part ready up to a certain extent. I could show you that if you're interested.
If it's okay for you guys. Yes, please.
1 second, I just have to ask. Anusha,
Yeah, that's
is it
fine. Go. It's fine. Go ahead.
Yeah, sure. I'm just going to share my screen.
Thank you very much.
Well, can you guys hear me?
Yeah.
Loading.
I can't see your screen yet, though.
1 second, it's loading. Can you see it now?
It's still loading. It's white. But while that loads, I did put in the chat a link to Open Bioeconomy Lab. I'm not sure if you guys are aware. They have a bunch of resources for bioreactors, and they have a GitHub repository. So you might want to check into that.
Yeah, I did check that out. And what we're doing is an industrial scale bioreactor setup. So it's a little different.
Okay.
1 second. My computer is not being able to share for some reason. I'll have some of the team members share it.
So any questions while Maurice is setting up?
Can you guys see it now?
Still black screen.
Sorry, not yet. Still black. Ah.
Yeah, there we go. We can see it.
So this is the entire thing. We wrote it on Jupyter notebooks, so that will be easier for us to collaborate. But yeah, that's the entire code as of now. Let me just run it for you all and show you all the output. going to take a little bit of time.
Anyone who has
So
questions,
here you
just feel
just
free to jump in.
really sorry about that. My Zoom crashed.
It is okay. I mean, the file is big, right?
Yeah, can you see it, guys?
Yeah.
Yeah.
Yeah. So here you would enter your tank volume, and here you would enter, say, a 2:1 ratio, and here you would have the CAD model. Here. Yep.
Nice. So basically, the
I know.
user can update it by using the cat or maybe through programming as well, right? Is it?
No, you would have a user interface where it would take care of everything. So we would give you all an advanced option where you all can choose exactly what parameters you all need and stuff like that. Okay, I don't know why the CAD model is not loading for some reason. Yeah, I have no clue what's happening. I think Zoom is having some trouble. I'll tell you what, I'll share a screenshot of this. One of the rest of the teams might be able to share it.
That's cool.
Just a quick question. So do you guys, where did you guys take the inspiration for these industrial designs? Was it from the small scale frugal designs already available in places like Amateur, the link, or how did you guys come up with the industrial scale thing that you guys had?
So I think that since we are mostly a engineering-based university, we just kind of came up with it by speaking to our professors and thinking about what is required. But I think we basically wanted it to be more DIY in the sense that from the CAD model, you can get the dimensions of the sheet metal and try to make it on your own. A design like that. I'm not sure. Just to test out. But
Also, when we were starting the design of our own bioreactor, we realized that they were just a simple rules that we had to follow. So why not automate the process altogether? And then we were like, why not just automate it for every bioreactor design? And, like whoever wants to automate it can just go ahead and put their stuff in the program, and you'll have a bioreactor design because it just follows a few simple rules. But why not?
but
Will
we've not. Yeah, go on.
So will it be applicable for smaller scale as well, since we've already optimized it for larger scale?
The current design is for the small scale bioreactor. The thing with the larger scale bioreactor, it's got a different set of rules, but very similar. So all we have to do is once we make the project open source, we could have a separate open large scale version, or depending on your volume, we can segregate them as large scale or small scale, and accordingly have the same software working both. We've made it such that any person, whoever reads the documentation once, can add in his or her own rules.
Yeah, sounds great. So